So, Kieran, what is AI vision from your perspective?
So I mentioned earlier, AI is a bit of a buzzword, and it means
Yes.
many
Yeah.
things to many people.
Yep.
So we were talking earlier about ChatGPT and things like that. All of that is AI. So AI, broadly speaking, is trying to replicate what humans can do.
Interesting.
So an AI vision system, at a very high level, what we're attempting to do is replicate what a human can do with their own eyes and brain.
Mm-hmm.
So they can see something, they can understand what it is, and then they can take action. Now, that action could be opening a gate, could be writing something down, it could be stopping a machine, it could be anything. But an AI vision system is basically replicating eyes and brain.
That's a very interesting perspective. I've just never thought of AI that way.
Yeah, I mean, there's lots of different sorts of AI.
Yeah.
There's autonomous vehicles. They will have
Mm.
AI vision systems on them. There are systems that will take invoices and scan them and then basically extract the information and upload them. And those are sort of optical character recognition AI systems. So there's a lot of buzzwords in there. There's your AI, there's machine learning, there's neural networks, there's things like that. But at a high level, you're trying to replicate what people can do.
Everything that you can see and translate to
Correct.
information. Well,
And you can see now why there's so many applications for this,
yeah.
because there's monitoring, there's security, there's safety, there's QA, QC, because all of these things require you to look at something, understand what that is, and then take action. Now, it could be letting it pass through, it could be taking records, it could be stopping the production line. All of these things are basically the same thing over and over again.
Can you kind of give me three examples where that could be implemented in the construction industry that would add crazy value to the industry today?
Yeah, there's a couple of examples, and I'll take some from Langer Rock.
Yep.
Langer Rock does a lot of precast in the UK through their factories.
Mm-hmm.
And it would be great if, as the precast was going through the production line, we could detect are the rebar placements in the right spots?
Right.
Are the at the end of it, are there any cracks in the concrete? Are there any issues with the facade? How we do that currently is there is a person that inspects it at the end. But if you know what it's supposed to look like, you can say to the AI, that's what I want it to look like, and alert me if it doesn't look like that. So basically, everything at every stage can be checked, and you can have a video, you can have the full QA reports associated with that, so that the panels do not even leave the factory. In fact, they don't even progress to the next stage. Now that's been in high tech manufacturing for a long time,
Right.
and that's a pretty established use case.
Mm.
But it's slowly filtering down to construction and heavy industries, where generally it's a much lower price point.
Mm-hmm.
You've got a computer processor versus a concrete panel, very different price points. So that's slowly filtering down to do that. Another example that we have is at the front gate, recording vehicles going in and out.
Yep.
And we had the example of it would be great to know what was going in and out so that we don't have to have the work experience kid writing it down on a piece of paper.
Mm-hmm.
So we could put an AI vision system on the front gate, for example, and it
Mm-hmm.
records the truck going in. If that license plate is not allowed to be on site, it says go over there and it calls the security guard. If it is, automatically open the boom gate, truck goes through, it videos the load going in, videos the load going out, timestamps everything, so that when you get the invoice, you can automatically reconcile that against what really happened. Now, there are other ways of doing that, GPS and logistics tracking software, but nothing beats literally a video of the thing that you want to look at. It's a
Sure.
sort of immutable log.
Yeah.
And finally, another example is what we'll be talking about, what we're focusing on is safety.
Yep.
So systems on the back of machines to alert you when a person or other specified object are around you to prevent accidents. So you can alert the operators and you can alert people around saying, there is a person next to you, stop.
Yeah. Yeah.
It's the same thing for us running different AI models.
Yeah. Kieran came up with that technology originally, didn't they? The digital barrier system to
Yes.
stop machinery going into the rail corridor.
Yeah, so the Kiwi Rail folks, in conjunction with a tech company, forgive me, I can't remember who it was now, we're looking at that. That system has some pluses and minuses.
Mm-hmm.
It's quite complicated to set up because you've got to set up barriers to say, if it crosses this area. So we've got a slightly different take, which is around safety. if there's a person there, for example, alert me. I'm sure we'll talk about shutting machinery down, which is
Yep.
an interesting topic.
Okay. So, but for all of this to be implemented, you've still got to have that AI trained. Yeah.
Yes.
Can you give me insights into the quantum effort that goes into training an AI model? Is it expensive? Is it time consuming?
Yes, is the answer to both of those. We spent about 5 years inside Langerock, and our
Yep.
efforts will never cease. Going from nothing to detecting a person 70% of the time, if you've got an AI engineer, it will take you an hour or two these days.
Yep.
To go from 70% detection of a person to 99.9, however many nines you want there, on
Yep.
a heavy industry site is very difficult. The reason for that is heavy industries are a series of edge cases strung together.
Hmm.
There's no equivalent of just driving down the road. There's always going to be some scenario that we've never seen before, and indeed a person's never seen before. So that's sort of point one, is heavy industries are edge cases. It's also very difficult to collect training data because typically you need thousands of hours of video and footage. And if I wandered into a construction site and said, do you mind awfully if I just record everything and use it for my AI training data? I know what the answer is, and it generally ends in something very rude. So it's how do you actually collect that training data?
Yeah.
Then the issue in heavy industries is typically we can't rely on a magical internet connection. So we can't rely on cameras being placed everywhere, feeding it back to a server. So we have to run what's called edge devices. So relatively low power devices that go out into the field or onto a machine. And that means you can't just run infinitely large AI processing models.
Yep.
So you have to take these potentially millions of images and shrink them down to build a model that will actually work in the timeframes that you talk about, milliseconds and things like that in the real world. And that's incredibly difficult. The other consideration for heavy industries is there's lots of edge cases that are not obvious what we should be doing. So, for example, if I see an excavator bucket, is that a vehicle or is that a vehicle attachment, or what category do I put that in?
Right.
Because if an excavator comes around the corner, the first thing I see is the bucket. So
Hmm.
maybe that is a vehicle. But if it's sitting on the ground, not attached to a vehicle, then that would get very annoying. There's things like high vis. So if I have a high vis jacket hanging up, it's indistinguishable to a person looking at that, whether or not that's a person, bending over, tying up their shoelaces, or it's a high vis jacket.
Just
So
hanging on a fence. Yeah.
exactly. So we're always faced in heavy industries with these sorts of issues that don't come up in sort of regular industry. And these are the reasons why heavy industries are so difficult to actually make the AI vision systems work, because they have to be relatively inexpensive. They've got to be very easy to use, and they have to work in these terrible environments that are very difficult from an AI perspective, but also they're hot, they're dusty, they are daytime, nighttime, they're covered in
Yeah.
snow and rain and things. That's the challenge, is making them ruggedized for heavy industries.
But
If
here's
I
the risk
had
as well, right? So you've just got to get it wrong once for them to shut you down.
So it's really interesting. There's something called a false positive,
Hmm.
and a false positive is, let's say, detecting an object as a person. It's clearly not a person. A
Hmm.
false negative is not detecting, let's say, a person that's really there.
Right.
And when I started many years ago, I assumed that people would prefer to err on the side of a false positive because it sounds safer.
Yep.
And that is probably true. If you had 100 detections and one of them was a false positive, nobody really cares that much. But if you had 100 detections and 99 of them are false positives,
That's a
then
problem.
people do care. And the
It's annoying.
operators, exactly right. And it's functionally useless for the operators.
Mm.
On the flip side, a false negative sounds dangerous, and arguably it is, but it never annoys the operators because whenever it goes off, there's definitely a person there. So you've got this trade off between potential safety in annoying operators and not annoying operators that actually will embrace using it versus a potential safety issue. And that's why all the AI is adjustable and we update it all the time. But you do have this fundamental issue. which is why we err on the side of caution. And it's back to that high-vis example.
Yeah.
That does not come up in other industries because people don't walk around in high-vis and put their hard hat on the top of a pallet while they're getting warm in the afternoon.
Yeah. Oh, could be high vis versus a traffic cone, and you get it wrong. Who knows?
Exactly.
Hopefully not.
So the other interesting challenge is compared with what? So an AI vision system, our systems are doing it in less than 200 milliseconds from image going in to alerts coming out. So compared with a person, you cannot react that fast.
No way.
So my question is...
Hang on, Lewis Hamilton couldn't react that fast.
Exactly.
Oh, sorry, let me keep it relevant. Oscar Piastri couldn't react that fast.
Indeed. So the question is, compared with what?
Yeah.
And if you compared it with a person, it's much faster and probably more accurate. Because what people do is they look at it for multiple sort of minutes or seconds, and they decide what they're looking at, and they look at it from different angles.
See, you're talking about the efficiency of that system, right? And there's no argument there, the efficiency of the system, right?
That's always accuracy versus precision, and how quickly you do it.
But I think you have another challenge there as well. So I have a Honda CR-V. Yeah, that's what I drive around, and it's got adaptable cruise control and it's got lane assist. Yeah, my wife would never use both those functions ever because she just doesn't trust it.
Yes.
So it's how do you then cater to my wife now, right? So who wouldn't then go? I wouldn't go adaptable cruise. Just follow the car in front of me. If the car in front of me brakes, your car automatically brakes. Yeah, you've set the speed limit. It's perfect, right? It's such a simple function. And she goes, I trust my own instincts and my own driving skills greater than that of the AI.
Yeah, I would argue with the wife's driving, whether or not that's true, but you raise an interesting point, which is interaction with the machines.
Mm-hmm.
So if we have a system on a machine and it takes control, not only does the AI have to be essentially flawless, but there are 5 considerations for why you might not want to do that.
Okay.
The first one is, are you introducing bigger safety issues? So if a vehicle takes control, take, for example, a forklift or a telehandler carrying a load. You've got a load that's potentially raised and moving, and all of a sudden the machine stops, and those loads start swinging around. You can tip over machines. The second one, which is to your wife's point, it's really irritating for the people using the machinery.
Mm-hmm.
So you have to be useful without being annoying. And the CR-V has obviously gone too far into the annoying without being useful.
For me, it's really useful, though.
Well, the third one is legal.
User-centric. Sorry, keep going. Third one?
Third one's legal. So if we start shutting machinery down or interacting with machinery and something does happen, whose fault is that? So, for example, on the CR-V, if it does something and results in you running into a car, are you suing Honda because they took control? Or is it your own fault? Or where does the liability lie here? 4 and 5 are actually the interesting ones for me. In heavy industry sites, the reason I personally at least don't hang around big yellow machines is because I don't want to be run over. But if I know that machine is always going to stop, there's no reason for me to change my behavior. I'll walk wherever I feel like.
Yeah.
And you actually weirdly make the problem worse in safety because everybody knows they don't have to change their behavior. And you're punishing the operator for the behavior of somebody else. Now, is that fair?
Interesting.
The final reason, which we've already spoken about, is the risk of false positives or the AI not understanding something. And the classic one is high vis. So you don't want to be shutting a machine down because somebody's hung their high vis jacket up there. What you want to do is alert the operator.
Mm-hmm.
They are not psychopaths trying to run their colleagues over. They simply didn't know that somebody was there.
Yeah.
If they knew that, they would put their foot on the brake. So I am very much in favor of AI systems like ours being used as assistive tools, not taking control. Now, in mining, they've got a different view. There's a program called Immersed Level 7, 8, 9, and 9 is full autonomy. And they do shut machinery down. So there is this tension of how good does the AI need to be and in what scenario is this actually going to work versus all these other legal, operator, practical considerations.
Yeah.
And back to your CR-V, it could effectively be an autonomous vehicle.
Yep.
Except for the scenarios that it doesn't know. And it's that 1 in 100, 1 in 1,000, where you're in the back seat, eating cereal or reading the newspaper, and it all of a sudden says, I don't know what to do at 100 kilometers an hour, and you crash. So heavy industries are very difficult because we've got all these edge cases. And that's why I generally err on the side of helping an operator or helping a person to do their job, not taking their job away from them.
Yeah, fair enough. Because if the machine does take control, then it's the 1 in the 100 case would always make the newspapers.
Yes.
The 99 times you'll never make the newspaper, but that
Yep.
one time you'd make the newspaper. And it's interesting, isn't it? It's really interesting. Yeah.